In this organic compound, which is the prefix? The prefix will be bromo. First compound in the homologous series of alkane is CH4. What is CH4? It is methane. Longest chain or the parent chain has to be identified. Once the longest chain is identified, yes, what we have to do? We have to start numbering the carbon atoms. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So in the last session, we discussed about the classification of organic compounds, right? The whole of the classification of organic compounds we discussed and we studied it in last session, right? And then we studied about functional groups as well as homologous series. And then we also begin with the nomenclature of organic compounds, right? We studied about prefix, the word root and the suffix, right? Yes. So now in today's session, we'll be studying about the IUPAC nomenclature of alkanes, right? We will be beginning with the IUPAC nomenclature of straight chain hydrocarbons. And then we will move on to branched chain alkanes, right? And then naming of cyclic compounds also we will discuss in this session, right? So in this session, we will be studying about the nomenclature in detail, okay? So first beginning with the arrangement of prefixes, word root and the suffix. So in the IUPAC name, yes, as we discussed in the last session, there will be a prefix, then a root word and then a suffix. So we are going to see the arrangement of this prefix, root word and suffix, right? So the order of IUPAC naming will be the prefix, that is prefix, right? So before the word root, the prefix will be there and then the root word and the primary suffix and then comes the secondary suffix, okay? So first the prefix will be written and then the root word, right? And then the primary suffix and then comes the secondary suffix. So we discussed in last session, right? Primary suffix will be if it is unsaturation is there, that is if it is alkane, alkene or alkyne, all those comes under primary suffix. And the secondary suffix is for the functional groups, right? Yes, okay. So let's take the first example that is shown here, right? CH3, CH2, CH2, Br. Okay, so in this case, that is in this organic compound, which is the prefix? The prefix will be bromo. As you can see, halogen is there, that is bromine. Okay, so that will be the prefix. And which will be the root word? It will be prop. Why? Because 1, 2, 3, there is a total of 3 carbon atoms. So the root word will be prop, right? And the primary suffix will be a. Why primary suffix will be ane? Because it is an alkane, right? No double or triple bonds, it is an alkane. So what will be the IUPAC name? It will be bromopropane, okay? Or more clearly, you can write it as 1-bromopropane, okay? 1-bromopropane. Why? Because on the first carbon atom, the bromine will be present, right? So if we number it, it will be 1, 2 and 3. So it can be more specifically written as 1-bromopropane. Okay. The next one, let us see. CH3, CH2, CH2, CH2OH. Now there is a functional group here. Now we know that the functional group is written in the suffix, right? Okay. So now what will be the prefix here? Any other prefixes here? Only the functional group is there which comes as a suffix, right? Okay. Now the root word will be but. Why? 1, 2, 3, 4, 4 carbon atoms. So the root word will be but, right? The primary suffix will be ane. It is an alkane itself, right? And the secondary suffix will be ol. Why? Yes, alcohol, if it comes, the suffix will end with, or the IUPAC name will end with OL. Right. So in the last session, we studied about this. If it is alcohol, it ends with ol. So what will be the IUPAC name then? It will be butanol. Okay. Right? Because there was no other prefix present here. Here, no prefix was present. It is just the root word and the, yes, the primary and secondary suffix. So I hope the order is clear for you. That is prefix, root word and then primary suffix and secondary suffix. Okay. Now moving on to the naming of alkanes. Okay. Specifically, we are going to see about straight chain alkanes. Okay. Yes. That is how you can name it. It will be the root word plus primary suffix. What is primary suffix? Whether it is alkane, alkene or alkyne. Based on that, it can be ane, ene, or YNE. Right? If it is an alkane, it ends with ANE. If it is alkene, ENE, alkyne, YNE. Okay. So the first organic compound or the first compound in the homologous series of alkane is CH4. What is CH4? It is methane. Okay. So this meth stands for what? That is the root word. That is only one carbon atom is there. That means meth. And the primary suffix is ane. Right? No other functional groups or prefixes here. Right? Now the second homologue is C2H6. C2H6, 2 carbon atom is there. So eth and ane, that is ethane. Third one is prop and ane, propane. Then butane, pentane. Right? The next one is C6H14. Right? So 6 carbon atoms means hex. Right? The root word is hex. And it will end with ane as it is an alkane. Yes, then heptane, octane, nonane and decane. Okay, so this is how you name the straight chain hydrocarbons. I hope it is clear. That is specifically alkanes. Okay, this is how you name the alkanes. Now moving on to the rules for naming branched chain alkanes. So in here we discussed was the straight chain alkanes. Now we are going to study about how to name the branched chain alkanes. If there are branches present, the naming will be different. So the IUPAC has set up certain rules for this. So each of these rules you have to remember, then only you can name the organic compound. Right. So the first rule is longest chain rule. That means the longest possible continuous chain of carbon atoms, including the functional group and multiple bonds, is taken as the parent chain. So when an organic compound is given to you, you have to identify the parent chain or the longest continuous chain. Okay, the longest possible continuous chain, which is called as the parent chain, has to be identified. That is longest chain rule. Right? So the longest chain or the parent chain has to be identified. So let's take this example. Okay, as you can see, a branch is here. That's why it is called as branched alkane. Right? Okay, so as you can see, 1, 2, 3, 4. Which is the longest chain here? It is this one. 1, 2, 3, 4. Okay, another possibility is there. 1, 2, 3. You can go this way as well. Right? But how many carbon atoms will be there in that case? Only 3. Right? So which will be the longest chain? It will be 1, 2, 3, 4. This will be your longest chain and this methyl group will be present as the branch there. I hope it is clear. Now moving on to, yes, so which will be the parent chain? Butane will be the parent chain, right? This is butane and methyl will be present as a branch there. Clear? So let's take the second example. In this case, 2 possibilities are there. How can I see which one is the longest chain? If I start from here, 1, 2, 3, 4, 5. Okay, this chain will have 5 carbon atoms. Now if I start from here, that is 1, 2, 3, 4, 5, 6. I get 6 carbon atoms. That means which will be my longest chain? This will be my longest chain, right? And this will be present as a branch. Clear? So based on the longest chain, that will be longest continuous chain, that will be your parent chain. So in this example, which is the parent chain? It is hexane, right? I hope it is clear, right? Now moving on to the second rule, that is the numbering is done in such a way that the branched carbon atom gets the lowest possible numbers. In case of unsaturated hydrocarbons, carbon atoms involved in double or triple bond should get the lowest possible number. So that means, what was the first rule? We have to identify the longest chain. That is done. Once the longest chain is identified, yes, what we have to do? We have to start numbering the carbon atoms. So the numbering should be done in a way that the branches that is present, that should be having the lowest number. Okay, the branches should be having the lowest number. Apart from the branches, if there is unsaturation also present, that means double or triple bonds. If it is also present, then those double and triple bonds should be getting the lowest number. Okay, so let's take an example and understand it. Okay, so as you can see in this particular compound, there is a branch here, there is a branch here, and there is a branch here. Right. So how do I number the carbon atoms? So I can start from here as well as I can start from here. Right. Both are possible. Let's see which one is the correct way. So if I start numbering from here, this is 1, this is 2, this is 3, this is 4 and this is 5. Okay. So these two methyl groups. That is, these two branches will get the number 2 and this will get the number 4. Right? My branches will get this number. If in the opposite way I am taking 1, 2, this methyl group will get number 2 and this will get number 4. So, that is how you have to see. So, in this case, yes, both of them, in this particular carbon atom, there are 2 methyl branches. So, what was the rule? The branches should get the least possible number. So, if in this way, it is getting 2. But if I am coming this way, this particular carbon will get the value 4. That means 1, 2, 3, 4, 5. This will be in the opposite order. So that means 2 methyl groups are getting number 4. So if 2 methyl getting number 4 or 2 methyl groups getting number 2 is the lowest possible one. 2 methyl groups getting the number 2, right? So this will be the correct order. That is 1, 2, 3, 4, 5, right? So that is how you name it. Okay. The next example, let's see. CH3CH and there is a branch here, methyl group, and then CH double bond CH2. Okay, so if there is a branch as well as double or triple bond, yes, which will get more preference? That means the number should be the lowest for the double bond. So instead of numbering it from this side, we number from that side. Why? Because 1, 2. Yes, the numbering, if we start from here, yes, the double bond will get the first number. But if I am starting numbering from this side, it will be 1, 2, 3, 4. My double bond will get the number 3. So which one is approved? Yes, this one is approved, right? So I hope it is clear. When a methyl group, that is a branch, and if a double bond is there, the double bond will be getting more preference. Okay. So I hope it is clear. Now moving on to the next rule, that is when the alkyl group in compound is attached as branch, then it is prefixed to the name of the parent alkane and the position of the substituent is indicated by appropriate number. So now we saw that there were few branches, right? What to do with the branches? How do I name it? So the branches are the, yes, the alkyl groups, right? The alkyl groups which are present as the branches, the alkyl groups has to be named as a prefix. It has to be named as a prefix of the parent alkane. You write the parent alkane before that. Prefix means it is before that, right? Prefix and the position of the substituents is indicated by appropriate numbers. We numbered the carbon atoms, right? So based on the numbering, on which carbon atom the methyl group or the alkyl group is present, that also have to be mentioned, right? If different alkyl groups are present, they are named in alphabetical order. Okay, so let's see. In this particular example, you can see a CH3, CH2, CH, and on this carbon atom, there is a ethyl group, right? This is ethyl. This is ethyl. C2H6 is ethane, C2H5 is ethyl, right? And in here you can see there is a methyl group as well, right? And then CH, CH2, CH3. So this is the organic compound. How do I name it? Yes, as said, the alkyl groups must be in the prefix, right? So which is the root word here? Or how many carbon atoms are here? 1, 2, 3, 4, 5, 6. And it is an alkane, right? Are there any double or triple bonds? No, right? All are single bonds. So it is hexane. So the root word will be hex and the primary suffix will be, yes, ane, right? Okay. Now what to do with the two groups, methyl and ethyl? Yes, they must be in the prefix. Also, appropriate numbers must be given. So in which order I have to number? It has to be numbered. Yes, we can number in this direction as well as this direction. Okay, so there is one ethyl group as well as methyl group. So in alphabetical order, ethyl or methyl comes first. Ethyl comes first, right? Ethyl comes first in the alphabetical order. So that should be getting the lowest number. Okay, so hence I number from here 1, 2, 3, 4, 5, 6. Okay, yes, if I am numbering from that side, it becomes 1, 2, 3, 4, 5, 6. So my ethyl group will get the fourth number, which is not correct, right? So this is the correct order. So where is the, which carbon atom is the ethyl group? Yes, 3 ethyl. You write it down. On the third carbon atom is your ethyl group. So you write that first. 3 ethyl. Yes, 3, then a hyphen, then ethyl. then again a hyphen has to be written, and then where is the next group? That is methyl. It is on the which carbon atom? 4th carbon atom it is present. So 4-methyl. Okay, so 3-ethyl, 4-methyl. Now the branches are named. That is the alkyl groups are named. Now what is your root word? Till here it was the prefix, right? Now what is the root word? It is hex and the suffix is ane. So this is the name. This is how you name the compound. Okay, so I hope it is clear, right? Now, in case there are 2 or more similar substituents, if there are 2 or more similar substituents attached to the parent chain, their positions are indicated separately and prefixes such as di, tri, tetra are used. So, if same substituents are present, okay, as in this case you can see, here there is a methyl group, here methyl group, here methyl group. All the, yes, alkyl groups are same. That is methyl. So, in that case, what you have to do? Separately, you have to mention the positions. That is based on the number. Separately, you have to indicate the positions of it. Also, you have to use di, tri or tetra based on how many alkyl groups are present. That means, let's take this particular example. Okay, so how do I number? 1, 2, 3, 4, 5, 6. Another possibility is also there. 1, 2, 3, 4, 5, 6. Which will be correct? In this case, this is getting 2. This methyl is getting 3. And this is getting 5. In the opposite way, if I take, this one will get 2. This one will get 4. This one will get 5. Okay. So, which one will be appropriate? The first one will be appropriate, right? So, that is the one we consider. So, now how do I name it? So, where all are the methyl groups present? Yes, on the 2nd carbon atom, on the 3rd carbon atom and the 5th carbon atom. So, the positions are written 2, 3, 5. Okay, 2, 3, 5. That is this part. That is positions are indicated separately. Wherever this, which and all positions is this present. That is 2, 3, 5. Then how many methyl groups are there? 3 methyl groups. So that is represented by tri. Okay. So 2, 3, 5 tri-methyl. It is all those things are same. If all the substituents are same, then only you can use this, right? So 2, 3, 5 tri-methyl. Now how many carbons are there? Coming back to the root word, prefix is done. Okay, so 1, 2, 3, 4, 5, 6 carbon atoms. It is an alkane. So the root word will be hexane. Okay, so I hope it is clear. Right, now coming on to the next rule, that is, if identical groups are present on the same carbon atom, then the locale number is repeated. Okay, if it is present on the same carbon atom. So in this case, one was present in the 2nd, one was in the 3rd, one was in the 5th. So we wrote 2, 3, 5. Now in the case if both are present in the same carbon atom, see, as you can see, both are present in the 2nd carbon atom. Both methyl groups are present in the same carbon atom. So, you have to repeat the number. It will be 2, 2 dimethyl pentane. In this case, 1, 2, 3, 4, 5. 5 carbon atoms. So, your root word is pent and suffix is a. Okay? Yes. So, if same substituents are present on the same carbon atom, it should be written, that is, that number should be repeated, 2, 2 dimethyl. 2 methyls are there, right? So, dimethyl pentane. Okay, clear. Now, moving on to the next one. When 2 substituents are found in equivalent positions, the lower number is given to one first in the alphabetical order. Okay, so if 2 substituents are found in equivalent position, then the lower number is given to the one coming first in alphabetical order. So, equivalent position means, see, in this case, you can see 1, 2, 3, 4, 5, 6, 7, 8. The numbering is done like this. In the opposite way also, we can number. That means 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, in this case, also the same thing is happening. The 3rd carbon atom has methyl. And the 6th one will have the ethyl group. Okay, this is the ethyl and this is methyl, right? Okay, so if I start numbering from there, it is 3 and 6. If I numbering in this direction also, it is again 3 and 6. So in both direction, if I number, the numbers are coming in 3 and 6, right? So which one I will choose then? 3 is coming in methyl, 6 in ethyl, or opposite way if I take, both are coming like that. So which one should I choose then? So the numbering should be done in a way that alphabetical order, which one is coming first, they should get the lowest number. So that means which one will be the appropriate one? It will be in this direction, right? Alphabetical order, ethyl or methyl come first? Ethyl comes first. So this one will be the correct numbering. 1, 2, 3. Ethyl should get the lowest number. Then 4, 5, 6, 7, 8. Clear? Okay. So methyl will get the 6th one. That is why this one is not approved. So this is when they are in the equivalent positions. From both sides, if we are numbering, we are trying to number. If they are in equivalent positions, then which one to choose? Which one is in the alphabetical order, which one comes first, that should get the lowest number. So that is how you number it. Okay. So how would you name this organic compound? Till now we studied how to name it. Yes, first alphabetical order, whichever comes first, that has to be named first. So in which carbon atom it is present? Third carbon atom, right? So it is 3-ethyl. Okay, 3-ethyl. And the second one is which carbon atom? 6th carbon atom. So it is 6-methyl, right? 3-ethyl, 6-methyl. And how many carbon atoms are there? Which is the root word? 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon atoms. So the root word is oct. And yes, what is the suffix? It is a alkane, right? So octane. So this will be the name of the compound. Okay. So I hope it is clear. Now moving on to the last one. If the substituent on the parent chain itself has a branched chain, then it is named as substituted alkyl group inside the bracket in such a way that the carbon atom directly attached to the parent is assigned number 1. That means in this particular example, you can see, okay, if the substituent on the parent chain itself has branched chain, okay, that means this is your parent chain and there is a branched here and itself is having another branched chain alkane. Okay, this is the parent chain, there is a substituent here and this substituent itself is having a branch. So in this case, how do you name it? Okay, so that is what we are going to see. So how do you name it? It will be, yes, on which carbon atom the substituent is present? On the 5th carbon atom, right? So if you are naming from this side, it will be 1, 2, 3, 4, 5. On that side also it is 1, 2, 3, 4, 5. So both are correct, right? So we take the 5th carbon atom and we write that 5 hyphen. And then we should start numbering this particular substituent. That is what is written. Directly attached to the parent chain is assigned the number 1. So this will be attached directly to the parent chain, right? So this will be 1, right? This will be 2 and this will be 3. Okay. So separately you have to name this branched chain. Okay. So inside your parent chain, if there is a substituent which itself is branched, you have to separately name them and put it in a bracket. Okay. So on which position it is there? 5th carbon atom. That is why 5 is written. Okay. So and the carbon atom which is directly attached to the parent chain must be numbered 1. So 1, 2, 3. Okay. So you can't name it in the opposite direction, number it in the opposite direction. It should be 1, 2, 3. Okay. So now you can name this particular one. 1, 2, 3 it is. So on the second carbon atom, there is 2 methyl groups. So a substituent on the same carbon atom means again you have to repeat the numbers, right? So in 5 you have to write the bracket 2, 2 dimethyl. 2, 2 dimethyl, right? 2, 2 dimethyl. Now what is this chain? 1, 2, 3. 3 carbon atoms. It is propyl, right? Is it propane? It is propyl, right? It is coming as a branch. So it is a propyl. Then you write propyl. And now coming back to the root word. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the root word is non and the suffix is a. So this is how you name it. Okay. So when in the substituent itself branches are there. Yes. Which one is directly attached to it? It should be numbered 1. And then you number it and name this and then put it in bracket and then add it to the your main IUPAC name. So I hope it is clear. Okay. Now moving on to the next one, that is cyclic compounds. How do you name cyclic compounds? Okay. So till now we studied straight chain alkanes and then branched chain alkanes, the rules we studied. Now we are going with cyclic compounds. They are named by adding prefix cyclo. The prefix cyclo is added to the name of the alkane having the same number of carbon atoms as in the ring. Okay, so the same number of carbon atoms as in the ring. So the name of the alkane is clear for you. From the root word, yes, based on the number of carbon atoms, we know how to name the alkane. So before that name, you have to put a prefix which is cyclo. That is how you name cyclic compounds. Okay, so the first one, let's see. Okay, as you can see, how many carbon atoms are there? 1, 2, 3. 3 carbon atoms are there. So 3 carbon means, which is the root word? It is prop, right? So which is the alkane associated with it? It is propane. So how do you name it? Cyclopropane. The prefix will be cyclo. For cyclic compounds or cyclo compounds, the prefix will be cyclo. So this one, how many carbon atoms? 4. So it is butane. So hence the name will be cyclobutane. This will be cyclopentane. Here 6 carbon atoms, cyclohexane. Right. So now coming on to this one. On cyclohexane, there are other substituents as well. So how do you name it? Yes, there is one CH3 here and one CH3 here. Okay, 2 methyl groups are there. So how do you name it? Okay, so the first one is numbered 1 and the second is 2. So 3, 4, 5, 6. You number the carbon atoms. It is a closed structure, so you number in that way. 1, 2, 3, 4, 5, 6. Okay, so now the same way as you named the branch chain alkanes, how did we study the rule? The same rule applies here. How do you name it? The alkyl groups must be present in the prefix. So in which positions it is there? 1 and 2. So 1, 2. How many methyl? 2 methyl, right? 1, 2 dimethyl. So the prefix is done. Now what is the name? It is cyclo. Yes, as it is a cyclo compound, that prefix is also present as the secondary prefix cyclo, and then hexane, right? Hexane, 6 carbon atoms, so hexane. Yes, I hope it is clear. Now moving on to the next one. Okay, how many carbon atoms are there? 1, 2, 3, 4, 5. Okay, so your root word will be, yes, it will be pent. Okay, now there is a cyclo group here and there is a substituent here. There is a methyl group here. And what is this present here? This is an ethyl group, right? So this part is CH2, you can see, and this is CH3. That means what it is? It is an ethyl group. So this particularly represents an ethyl group, right? Okay. So which one? We studied before itself. If an ethyl group is there and methyl group is there, which one will get more preference? It will be ethyl. So from where I have to start naming? It will be from here. Numbering. It will be from here. 1, 2, 3. Right? The numbering should be 1, 2, 3 and not 1, 2, 3. Then numbering should not be in this direction because ethyl should get the lowest possible number. So it will be 1, 2, 3. Clear? So how do you name this now? Yes, on the first carbon atom there is an ethyl group. So 1 ethyl. Right? Now in the third carbon atom methyl substituent is there. 3 methyl. Yes. Now cyclo. And how many carbon atoms are there? 5. So it is pentane. 1 ethyl, 3 methyl, cyclopentane. Clear? Now moving on to the last one. Okay. So as you can see here, 2 substituents are there. 1 methyl is here, 1 methyl is here. Okay. And then you can see here 1, 2, 3. So what it is? Yes, it is a propyl group, right? So how do you name the organic compound? It will be 1, 1 dimethyl. How do you name it? 1, 2, 3. Numbering is done like this. So 1, 1 dimethyl, 3 propyl cyclobutane. So the root word will be but, and yes, as it is an alkane, it is a butane. Okay, so I hope it is clear. Now moving on to the next one, that is, if the side chain contains more number of carbon atoms than those in the cyclic ring, then the compound is considered as a derivative of alkane and the ring is considered as a substituent. Yes, so in all these cases, how did we name it? Yes, the root word or this was the parent chain and the propyl group was the substituent there. Yes, because here 1, 2, 3, 4, 5, a total of 5 carbon atoms are there. 5 carbon chain it is. That is, your parent chain is a 5 carbon atom chain. And the substituent is having only 3. But if it is having more than that, that means, let's take this example. Okay, the parent chain 1, 2, 3, 4, only 4 is happening. And whichever substituent is attached to it, 1, 2, 3, 4, 5, it is having 5 carbon atoms. Okay, so now this will behave as the parent chain and this will be your substituent. Earlier it was different because yes, whichever is having longest chain will act as the parent chain, right? So in this case it is having more number of carbon atoms, means that will be the parent chain, and cyclobutane will be your substituent, right? So then how would you name it? It will be 1-cyclo, right? On the first carbon atom there is a cyclobutane. So 1-cyclobutyl, yes, 1-cyclobutyl pentane. Okay, so this is pentane, 1, 2, 3, 4, 5. This is a pentane, and on the first carbon atom there is a cyclobutyl group which is present. So 1-cyclobutyl pentane it will be, and it's not 1-pentyl cyclobutane. Okay, it won't be 1-pentyl. Okay, it will be 1-cyclobutyl pentane. Okay, the same way you can see here as well. There is a alkane which is present, straight chain alkane. Yes, 4 carbon atoms are here, and in the cyclo compound only 3 carbon atoms. It is a 3 carbon atom chain. So which one will be? Yes, the longest parent chain or the longest chain, it will be this one and not your cyclo compound. So how do you name it? This will be the substituent and this will be the longest chain. Hence that will be the parent chain. So how do you name it? On which carbon atom it is present? Second carbon atom. So 2-cyclopropyl. Cyclopropyl it is, right? So 2-cyclopropyl, 1, 2, 3, 4, it is butane. 2-cyclopropyl butane. So that is how you name it. Okay. So I hope the naming of cyclo compounds is also clear for you. So in the next session, we will be studying about the nomenclature of organic compounds containing functional groups. Now, when the functional groups comes, how to name it, we'll be seeing. And the naming of compounds with polyfunctional groups, more than one functional group is coming, means which will get the priority, and based on all of that, how you can name the organic compound, and the nomenclature of substituted benzene compounds. On benzene, if there is any other substituent present, that is called as substituted benzene compounds, right? So for the naming of that compounds as well, we will be studying in the next session. So I hope what and all we have studied in this session is clear for you. So that's all for today. Thank you.